Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on net ionic equations. Alright, so what is a net ionic equation? So a net ionic equation just removes anything that's not an active participant in the chemical reaction. So to write our net ionic equation, we first need an ionic equation. So we separate everything that's aqueous into cations and anions. So every single compound only has one cation and one anion. So any compound can only separate into two parts. Basically, anything that you're starting with is aqueous. So all of our reactants are going to be aqueous. Even if it doesn't specify that they're aqueous, they are aqueous. Precipitates that are labeled with an S, water, which will be labeled with an L, and gases, which are labeled with a G, will stay together, so we do not separate those. So precipitates are solids, which is why it's an S, water is a pure liquid, which is why it's an L, and gases are gases, that's why it's a G. Aqueous is not a pure liquid, it means that something's dissolved in water, so that's why it doesn't get an L symbol. So once we separate everything that needs to be separated, we cancel out any ion that is present on both sides of a reaction. All right, so an ion has charges. So Na by itself is an element, Na plus or Na plus 1 is an ion. So any ion that's present on both sides gets canceled out, and then I just bring down everything that's left, and then I balance the final equation. All right, so let's do some examples. So here, the examples we're looking at, there's no aqueous listed, but there is a solid here. If there's nothing listed behind it, then you can assume that it is aqueous. So since the SrNO32 doesn't have anything behind it, we can assume that it's aqueous. So aqueous, aqueous, and aqueous. So if it's aqueous, we separate it into two parts. So NO3 is going to be together because it's in parentheses. Sr is by itself. Sr is in group 2, so it has a 2+ charge. NO3 is a polyatomic ion, so we can look at the back of our periodic table and see that it has a minus charge. So this separates and is now Sr2+ and NO3-. This 2 does not need to come with me here because it is not a part of my polyatomic ion. I don't bring with me any subscripts that are not a part of a polyatomic, and elements by themselves will not have any subscripts at all. So next we have NaI. It's also aqueous, so it separates into Na, which is in group 1, so it's a +1 charge. I is in group 17, so it's a -1 charge. All right, so now we go to the other side of our equation. So we look here, Sri2 is listed as a solid, so that means that it doesn't separate. So I leave it together. Anything that has a symbol after it that is not aqueous, so if it has an S, an L, or a G, I leave it together. And then lastly, I look at NaNO3, and that's aqueous, so that separates into Na+, and then this whole NO3 is together, and that's a polyatomic ion again, so that's just NO3-. Whenever anything has a 1+ or a 1- charge, you can write it as 1+ or 1-, or you can just leave it as plus and minus, and that's totally fine. The only time you need numbers is if it's a 2 or a 3 charge. Okay, so now we are going to cancel out things that are the same on both sides. So Sr2+ is an ion on one side, but it is part of a solid on the other side. So since they're not both ions, I cannot cancel them. NO3 is an ion on both sides. I have NO3- here, NO3- here, so those can cancel. Na+ is an ion on both sides, so those cancel. A- is an ion on the left, but it is part of a compound as a solid on the right, so it does not cancel. All right, so I look at what I have left. Sr2+ plus I- yields Sri2 as a solid. I always bring any state of matter that's not aqueous down with me so that I know why it is that I kept them together. All right, and then my final step here is to balance. This charge does not tell me how many I have. This charge only tells me what the charge is. So there's no number in front of or behind the Sr on the bottom, so that means I only have 1. I only have 1 here. I only have 1. I2, I have 2 here, so I'm going to put a 2 there to balance that. So my balanced net ionic equation is Sr2+ plus 2I- yields Sri2 as a solid. If you don't put the charges on the left side when they're ions, it's wrong. You have to have the charges in order for it to be correct. It cannot be a net ionic equation if there are no ions. and you cannot have ions without charge. Okay, let's do a couple more. Here, there's nothing behind here, so this is aqueous. Nothing behind here, so that's also aqueous, and nothing behind here, so that's also aqueous. All right, so now let's separate. So K is in group 1, it's a +1. I can only have 2 parts, which means that the OH has to be together. So I look on the back of my periodic table, and I see that OH is a -1 charge. All right, next I have MgCl is aqueous, so it separates into Mg, which is in group 2, so it's a 2+. Cl is in group 17, so it's a 1-. And then I look at the product side. This is a solid, so it stays together. Cannot separate things that are solid. And then I put that S there to indicate that it's a solid. And then finally K, Cl is aqueous, so I separate that into K+ and Cl-. All right, so now I check. I have K+ on both sides, so those can cancel. OH- is part of my solid, so it doesn't cancel. Mg2 plus Mg is part of my solid, so that doesn't cancel. Cl- and Cl- are both ions, so those cancel. So now I have OH- plus Mg2 plus yields MgOH2 as a solid. I have OH-, I have 1 here, I have 2 OHs here, so I balance that. 1 Mg, 1 Mg, so that's balanced. Excellent. Next up here, this will be aqueous, this will be aqueous, and this will be aqueous. All right, HI is aqueous, so that separates into H is in group 1, so it's 1+. I is in group 17, so it's 1-. NaOH also aqueous. Na is in group 1, so it's 1+. I can only have 2 parts, so that means that the OH is together. So that is a polyatomic with a -1 charge. And then we go to the other side. NaI is aqueous, so that separates into Na+ and I-. Ions that are on the right will already be on the left. So whatever the charge, like if Na was a plus on the left, then it's also a plus on the right. If I is a -1 on the left, it's also a -1 on the right. So once you find it, once you don't have to go back and find it again, it's just going to be the same. All right, and then we look at H2O. H2O is a liquid, not aqueous, so that means that I leave it together. And then I put that L there to indicate that it's a liquid. H+ does not cancel here because H2O is part of the liquid. I- and I- cancel. Na and Na cancel. And OH- can't cancel because there's no OH on the other side at all. All right, so this is going to be H+ plus OH- yields H2O as a liquid. I have 1 H here and 1 H here, that gives me 2. I have 2 over here, 1 O here, 1 O here. So that means that my equation is already balanced. Next up, we have LiCN will be aqueous, HF will be aqueous, that's a gas, and this will be aqueous. All right, so now we look at this, and Li is in group 1, so it's a 1+. Since we can have only 2 parts, that means that the CN has to go together, which means it's a polyatomic. If I look at the back of my periodic table, I see that it's cyanide and it has a -1 charge. HF is aqueous, so H is in group 1, so it's 1+. F is in group 17, so it's 1-. And then HCN is a gas, so gases have to stay together. And then LiF is aqueous, so Li+ and F-. All right. Li is an ion on both sides, so those cancel. Cn is part of the gas, so it doesn't cancel. H is part of the gas, so it doesn't cancel. F- is by itself, so those cancel. And I'm left with Cn- plus H+ yields HCN as a gas. 1 Cn, 1 H, I am balanced. Okay, so if I know what is a solid, liquid, or gas on the product side, then doing the net ionic equation is relatively straightforward. In the situation where we don't know what is the solid, liquid, or gas, then we have to figure that out. So I check my products. I first check to see if I made any water. If I did, I label that as a liquid. Then I check to see if I make any gases. The gases that will be in any problem we do will be in this list of common gases that are given here: NH3, CO2, HCN, and H2S. If it is any of these gases, then I put a G behind it and it's a gas. If it's not a gas or it's not water, then it's going to be a precipitate, which means that it's going to have a precipitate forming ion in it. So I check to see which product has the precipitate forming ion, and then that whole product is my precipitate, and I put a solid behind it. Anything that is not a solid, liquid, or gas, doesn't fall into those categories, remains aqueous. So let's take a look at this here. So I have BaSO4 plus K2SiO3 yields BaSiO3 plus K2SO4. All right, so I check to see first, did I make any water? I did not. No. All right, and then I check to see if there are any gases. NH3, CO2, HCN, H2S, none of those. So that means there has to be a precipitate forming ion. So if I go through my list here, I can see that Ba is a precipitate forming ion. So that means that BaSiO3 is a precipitate. So the precipitate is the whole thing that has the precipitate forming ion. And that's it. So now let's do our net ionicking. So anything that doesn't have a symbol behind it is automatically aqueous. So BaSO4 is going to be aqueous. Ba is in group 2, so it's 2 plus. Since I can only have 2 parts, that means that the SO4 is going to be together. If I check the back of the periodic table, I see that's sulfate and it has a 2- charge. K2SiO3, also aqueous. So K is in group 1, so it has a +1 charge. Everything else has to be together, so this is going to be SiO3, which is the silicate ion, and it has a 2- charge, and I can find that information on the back of my periodic table. And then we have BaSiO3. We said that that was the solid, so that stays together. And I put an S to indicate that. And then lastly, I have K+, and then I have SO4, 2-. So if I look at this here, I have K and K cancel, and SO4 and SO4 cancel. Everything else is part of my solid. So this is going to be Ba2 plus SiO3 2- gives me BaSiO3 as a solid. 1 Ba, 1 Ba, 1 SiO3, 1 SiO3 means that this is balanced. All right, next we're going to go through our checklist again. So here we check to see if we make water, and we do. We made some water, so that means that this is going to be my liquid. And then just to make sure that this isn't anything as well, NH4Br, not a gas. NH3 is a gas, but it has to be by itself. This is at H4. It's not the same thing. And then none of the precipitate forming ions are in this, and so I'm good. That's aqueous as well. Okay. So now I go through and I separate. So H plus, Br minus. NH4 is a polyatomic and OH is a polyatomic. So NH4 is ammonium, it has a 1+ charge. OH minus is hydroxide, it has a 1- charge. Again, all of that's on the back of the periodic table. All right, and then NH4Br breaks apart to NH4+ and Br minus. And then lastly, that water stays together because it's a liquid. All right, NH4 plus cancels and Br minus cancels. So I'm left with H plus OH minus yields H2O. As a liquid, 2 H's and 1 O means I'm balanced. All right, let's look at another. So here I check to see, did I make any H2O? I did not. Did I make any gases? I did. H2S is a gas, so I'll put a G behind it. All right, and then just to double check, RbClO4 is not any precipitate forming ion, so that's all I got. So H is a +1 charge, and then all of this is together, so ClO4 is a polyatomic with a 1- charge. Rb is in group 1, so it has a 1+ charge. S is in group 16, so it has a 2- charge. And then Rb again is 1+, and ClO4 is 1-. And then lastly, I have H2S as a gas. H's don't cancel, the ClO4s cancel, and the Rb's cancel, but the S does not cancel. So I'm left here with H plus S2- yields H2S as a gas. 2 H's here, so I need to put a 2 here to balance that. 1s, 1s. All right, let's look at one last one. So here we're going to check to see, did I make any water? I did. So that means that this is going to be a liquid. And then I just want to check to make sure I didn't make anything else. NaNO3 is not a gas. Nothing on the precipitate forming ions. CO2 is a gas. So in this case, I actually have two things that are not going to separate. Doesn't happen very often, but we can have that happen. So in this particular case, since it did, we have H2O and we have a gas. Go team. Okay, so we separate out anything that is not CO2 or H2O. All right, so Na is going to be a 1 plus, and then all of that is together. This is CO3 2 minus, and then H is 1 plus, and then all of that is together, and NO3 is 1 minus. CO3 is carbonate. We can find it on the back of the periodic table. NO3 is nitrate. We can also find that on the back of the periodic table. All right, and then Na separates from NO3. Na is a plus 1. NO3 is a minus 1. Right, and then we have CO2, which is a gas, and we have H2O, which is a liquid, so I don't separate either of those. All right, so let me check now to see what does go away. So Na plus and Na plus can go away. And then CO3, there's a CO3 here and a CO2 here. CO3 and CO2 are not the same thing. And CO3 has a charge. It's an ion. It's CO3 2 minus, but CO2 is a gas and it doesn't have a charge, so it doesn't cancel. So the CO3 cannot go anywhere because it doesn't have a matching part on the other side. H plus also cannot cancel because it's a part of the water now. NO3 can cancel because it's an ion on both sides. So here I have CO3 2 minus plus H plus yields CO2 gas plus H2O liquid. All right, so I have 1C, 1C, I have 3 O's, I have 2 O's here and 1 O here, so I have 3 O's, so I'm good there. I have 1 H and 2 H's, so that means I need to put a 2 here to balance that. All of my net ionic equations are very straightforward in balancing, so if you find yourself having to do a lot, it means that somewhere along the lines you probably did something incorrectly. So that is net ionic equations. This has been another episode of Chemistry with Wikipedia, tutorial edition. I hope you learned something, and until next time, keep on chemin'.